everyone. We're going to evaluate the limit, if it exists, of this function here. Of course, if you plug in 0, you'll get that it does not exist because you can't divide by 0. So we're going to have to rearrange this. Once you get to calculus, you really need to know your factoring facts. So we're going to break this down here, and we're using this one, a binomial expansion. So let's use that and break this down a little bit. So you have the limit as h approaches 0, and this is going to break down. Remember, in this case, your a is x, and your b is h. So this is going to write out as x cubed plus 3x squared h plus 3x h squared plus h cubed. And then we're going to subtract this x cubed all over h. Now, what happens is these two cancel out. So let's rewrite this again. The limit as h approaches 0 of 3x squared h plus 3x h squared plus h cubed divided by h. As you can see, what we can do is factor out an h in all of these. So that's what I'm going to do. I'm going to factor out an h. We get the limit as h approaches 0. Put h. We're going to have 3x squared plus 3xh plus h squared divided by h. So this domain is h cannot be 0. So when I cross these two out, it changes. But the equation changes, but the limit does not. The limit will be the same. That just means we're going to have a hole where we have the 0. So the limit as h approaches 0 of 3x squared plus 3xh plus h squared. At this point, all you're going to do is plug the 0 in for all your, h's, not x's, be careful. So in all your h's, and what you're going to get is 3x squared plus 3x times 0 plus 0 squared. And so your final answer is going to be 3x squared. Let me erase this. And this is kind of a startup to where we're going to start talking about the derivative. And that's going to be after this class. That's it. Thank you. Have a nice day. Bye-bye.